Disk scheduling, the shortest seek time first disk scheduling algorithm. Understanding disk scheduling algorithms is crucial for optimizing performance. One of the most effective algorithms is the shortest seek time first SSTF disk scheduling algorithm. This study is about determining the total distance in cylinders that a disk arm traverses to satisfy pending requests. Understanding disk scheduling. Disk scheduling is a method used by operating systems to manage read and write requests to a disk. These requests can arrive in a random order, and the operating system must decide the sequence in which to process them. The primary goal is to minimize the time the disk arm spends moving, thus improving overall system efficiency. About the SSTF disk scheduling algorithm. The shortest seek time first SSTF disk scheduling algorithm is designed to reduce the average seek time by servicing the request that is closest to the current position of the disk arm. This approach prioritizes requests based on their proximity, effectively minimizing the distance the disk arm must travel. How SSTF works. To determine the total distance in cylinders that a disk arm traverses using the SSTF algorithm, follow these steps. Identify the current position. Start by noting the current position of the disk arm. List pending requests. Gather all pending requests, which are typically represented as cylinder numbers. Calculate distances. For each pending request, calculate the distance from the current position of the disk arm. Select the nearest request. Choose the request with the shortest distance from the current position. Update the position. Move the disk arm to the selected request and update the current position. Repeat. Continue this process until all requests have been serviced. Calculating total distance in cylinders. To determine the total distance in cylinders that a disk arm traverses using the SSTF algorithm, follow these steps. Step 1. List pending requests. Assume you have the following pending requests in cylinders: 10, 22, 5, 18, and 30. Let's also assume the disk arm starts at cylinder 15. Step 2. Calculate distances. From the current position 15, calculate the distance to each pending request. Step 3. Select the closest request. The closest request is at cylinder 18, with a distance of 3 cylinders. Move the disk arm to cylinder 18. Step 4. Repeat the process. Now, from cylinder 18, repeat the process for the remaining requests 10, 22, 5, and 30. The closest request is at cylinder 22, with a distance of 4 cylinders. Move the disk arm to cylinder 22. Step 5. Continue until all requests are satisfied. Continue this process until all requests are processed. The order of requests processed would be 18 right pointing arrow, 22 right pointing arrow, 10 right pointing arrow, 5 right pointing arrow, 30. Total distance calculation. Now, sum all the distances traversed. From 15 to 18, 3 cylinders. From 18 to 22, 4 cylinders. From 22 to 10, 12 cylinders. From 10 to 5, 5 cylinders. From 5 to 30, 25 cylinders. Total distance equals 3 plus 4 plus 12 plus 5 plus 25 equals 49 cylinders. Advantages and disadvantages of SSTF. Advantages. Reduced seek time. By always choosing the closest request, SSTF minimizes the average seek time. Improved performance. This leads to better overall performance and responsiveness in disk operations. Disadvantages. Starvation. SSTF can lead to starvation for requests that are far from the current position, as they may be indefinitely postponed. Complexity. Implementing SSTF requires additional overhead for calculating distances, especially in systems with a high volume of requests. The shortest seek time first SSTF disk scheduling algorithm is an effective method for managing disk I/O requests by minimizing the total distance in cylinders that a disk arm traverses. By understanding how to calculate the total distance and how the algorithm selects requests, learners can appreciate the efficiency of SSTF in operating systems. Understanding the SSTF disk scheduling algorithm not only helps in optimizing disk operations but also lays the groundwork for exploring more complex scheduling algorithms.